one is a smaller charge, this one has a bigger charge. How am I going to show that in my diagram? Anyone?
Won't you only draw like the fourth line? Won't it be bigger?
Big, what do you mean by bigger?
So like the length of them would be longer.
Okay, the length actually doesn't matter. But you're on the right track because it's the how many lines you have. Remember, the same with magnetism. If I want to show that there's a bigger field, or a stronger field, would be a better word, then I have to draw them closer together. So you would draw the lines going out. So I always say do the sides first. Go 1, 2, 3, 1, 2, 3, and then you decide on the direction. So if it's a positive charge, electric field is always away from a positive towards a negative. It's the other way around as what electrons do. So you're always going to draw your arrows away from the negative. So there you'd already get some marks. Then because it's going away from this positive, but it's also going away from this positive, they're going to do this because they're going away from both positives. So that will give you your 2 marks already because you've got the shape right and you've got the direction right. The next one is the little bit of a thinking question, and you needed to realize that the 10 one will have more dense lines. So all you do is between some of these lines, you just go and draw other ones, so that you have more lines closer to each other for the one with the higher charge and less for the one with the lower charge. So remember, field strength is shown by the density of the lines. Not the length doesn't really matter, because as I go further, they're going to go further apart from each other as well. If I just doing this, if you look at those lines, as I go further, this distance here is close, further. So it doesn't matter if I make them longer. I'm not making the field stronger. I'm actually making the field weaker because I'm going further. Okay, you happy with the diagram, guys? That's quick, easy marks. Supposed to be. 2 of those were at least quick and easy. Now they say the 2 spheres are brought together and allowed to touch each other. The spheres are then separated to a distance 1.8 apart. When 2 spheres touch, what will they always do?
I want to say transfer electrons.
Yes, the electrons will move so that they all are the same. So the quick, easy way we did this, we said they're sharing the charge. So what you are doing is the quick, easy way to do it is you're just going to say plus 6, plus 10, because they both have a lack of electrons, so they both have a positive charge, and you're just going to divide it by 2. So this is going to be the new charge on each of them. So the new charge is always going to be add them up and share them, because when you touch objects, they're going to share whatever charge they have. And that means that the new charge on them is going to be the 16 divided by 2, which is 8. But remember the nanocoulombs, don't forget. So it's times 10 to the minus 9. So this will also be times 10 to the minus 9. Don't lose marks because of conversion. So that would be the new charge on each of the spheres. Add them up, divide by 2. Alright, but that is not the number of electrons transferred. Now you can look at any of them. The next question says calculate the number of electrons transferred. So now if you look at this, it went from plus, very important, you have to put the plus, because it's a charge, it's a positive or a negative charge. This one went from plus 6 to plus 8. What is the change in charge? So the change in charge would be the electrons transferred. So what is the change from plus 6 to plus 8? Guys, what's the difference between 6 and 8?
Plus 2.
2. Okay, and if you look here, so they go, so plus 2. If you look here, the other one went from plus 10 to plus 8. So what's happened here? What's the change in charge for this one? What's the difference between 10 and 8?
Minus 2.
Say minus 2. So the one is gaining electrons, the one is losing electrons. So the one that's minus 2, the change in, so it went from plus 10 to plus 8. So this one is gaining electrons. If it's if the change is negative, it's gaining electrons. Remember, they also ask that sometimes. And the one that becomes more positive is losing electrons. But and the number must always be the same. If you do this and it's not the same number, you've done something wrong in your calculation here originally. So now to get the number of electrons transferred, this equation is not on your information sheet. It is the change in charge over the charge on one electron that you can get on your information sheet. So it's not going to be the 8 that they end up with. They said electrons transferred, and that's why you have to look at the change in charge. So it's going to be 2 nanocoulombs, so 2 times 10 to the minus 19. Please look out for nanos and micros and stuff in the field question. It's always there. And what is the charge on one electron?
It's 1.6 times 10 to the power of 19.
And now it becomes calculated job, and you can put it in your, remember, don't type that in. That if they're both the same power of 10, save time. Time is a thing in physics. So just 2 divided by 1.6, and you get your answer 1 point something. Wait.
Isn't anode negative 9?
I was just going to say I definitely made a mistake, because there has. Why did I know that I'm making a mistake? Because please remember, the powers of 10 are important. This is 2 times 10 to the minus 9. This is 1.6 times 10 to the minus 19. So that means I'm going to end up with a 10 to the positive 10. And that makes sense because electrons are tiny things. So I have to have millions of them. And this 10 to the minus 10, if I end up with 1 point something, I can't have 1 point something electrons moving. So that means that's why I immediately knew I did something wrong. Okay, so please remember that in the exam. Think about your answer if it makes sense. So you can just do that, and that's the calculator job. Okay, now the last question we already actually answered. It says, did the electrons move from R to T or from T to R? So you already know, that T gained. So where did they go? From R to T or T to R?
R to T.
Good. From R to T. And that is all you write. Please do not explain. It's a 2-mark question. While we are marking, we're going mad because people explain stuff that they don't have to explain. If the answer says, Wayne said this, is he right? You write yes or no. You don't explain why Wayne is yes or right if the question is right or wrong if the question didn't ask for it. Please, guys, physics is important that you have to work with your time productively. Okay, third sphere. So this is the higher order type of question. Okay, so Coulomb's law. Please, guys, there are going to be 10% of definitions. You need to learn them. Now, Coulomb's law, they say a third sphere, S, with a charge of -5 is placed between the spheres at a distance T. Okay, and again, the question here says, calculate the magnitude of the net force acting on sphere S due to spheres R and T. So when you get a question like this, highlight the one that they are asking about. They say the net force acting on sphere S. So we are interested in sphere S. Often people swap values around, so do that first. Think for yourself, which one am I asked about? Now the question says force. If the question says force, how many objects are involved in a force between two objects? I just said it. In a force. Which equation? Okay. Which equation am I going to use? I'm going to pick on you, Jess, for this one.
Ma'am, it says force. And then it says 1. Oh, Jesus, I'm bad at this.
That's why I'm picking on you. If you have
I really
two
cannot like this one.
if you have
so-
two objects and they're asking for a force, look at your information sheet and look for F. That's all you're doing.
That's the F is equal to G times M. Well, no, F is equal to K times Q1, Q2 over R
Okay.
squared.
Good. Please remember we are not working with masses now, we're working with charges. So it's K, Q1, Q2 over R squared. Yes, so that's your step one. Think of the equation. But now if we look at that S, which the question is giving us. S, there's a force here between S and R. S is negative, R is positive. Which way will the force go between S and R? Which way will it pull S? To the left or the right?
To the
To the
right.
right.
Guys, this is a
To the
positive.
left.
Thank you. A positive and a negative, what do they do with each other?
They attract.
They attract. So if these two are attracting each other, which way will S move because of R?
I thought you said
Sorry.
which way is R moving?
Oh, did I? I'm sorry. I meant S because the one that's highlighted, if I said that, then you were right. But we're looking at S. That's why we highlighted S. We want to see which way S is moving. Okay, so then you guys did get it right. So S will be moving to the left because it's attracted by this positive charge. Now, so there's a force, so there's two forces acting on F. It's this one, which is F between R and S. That's why this question is 6 marks worth. But then there's another force here between S and T. So we can call that FST. So now there's a force between them. Which way will this green force pull S?
Yes, but I don't think to as a stronger extent as R.
Okay, but you don't have to even worry about that yet because we're not worrying about the sizes yet. We're just thinking about the forces. So yeah, you're right. But now if we're looking at this force here, I just want to see the direction. So we know that because this is positive and negative, that T will attract S. So now if you draw a free body diagram, remember my free body diagrams is the best thing. This is FRS. And this is FST. They're asking us for the net force acting on sphere S. So if I want the net force, I need both those forces. So I need to go and that's why I said it's 6 marks because you need to go and calculate both forces. So for the one you're going to say, okay, this is QR and this is QS. And this is the force between R and S. And you put in the right values. Guys, please don't put in the wrong values. So here you're going to say K, which you read from the information sheet. What is it? 9 times 10 to the minus 9? Am I right? Am I choosing the right one? Wait, you've got your information sheet.
9 times 10 to the positive 9.
Okay, thank you. 9 times 10 to the 9. QR is the charge on R. So that is going to be 6 times 10 to the minus 9. QS is going to be 5. You don't have to worry about the signs because we already decided about attraction or repulsion. If you put it in, it's not going to really make a difference. Times 10 to the minus 9 because it's all multiplication. And then we're going to say over the distance, and the distance was given to you as 0.7 meters. So it's going to be 0.7 squared. And you go and get your answer. I'm going to make up an answer. Or does anyone want to do this on the calculator quickly? Is someone doing it? Okay, I'm going to assume no one's doing it. So I'm going to then just assume an answer. It's not the right answer. So you get the answer, proper answer on your calculator, and you work it out, and I'm going to make up an answer and just say, let's say it is to 20 Newton. Yes, did someone work it out?
It's 5.5 times 10 to the negative 7.
Thank you. So now we know this force between that's pulling it to the left has that size. So this is already 3 marks. Okay, so once you've done that, oops, why am I doing that? Now you're going to do the same for the other force. Now you're going to say, fine, I also need to get this green force, the force between S and T. So now the values are just going to change. This is going to be S and this is going to be T. This is still 9 times 10 to the 9. S is still 5 times 10 to the minus 9. This will just become 10 times 10 to the minus 9. And the distance, they've given us the total distance as 1.5. And that distance there, remember we are interested in this distance between the two objects. So this is going to be 1.8 minus 0.7 meters. So this distance is not going to be 0.7 anymore. It's going to be 1.1 squared. And that's why this will only probably give you 1 mark, because you're doing the same calculation just with different values. And now you're going to get that other force, this green force. Can you guys work it out for me again, please? Natalie, are you on it?
Yes, ma'am.
Guys, the rest of you can also do it.
I got 3.7
Yeah?
to the 10 to the minus 7.
Is that what you got as well, Natalie? Or anyone else that's
I
working?
don't know what I did, but I got a weird answer.
What did you get? Is it times 10 to the minus something?
Yeah, times 10 to the negative 7.
So you got the same answer. Okay, Natalie, you probably just typed too fast because I was putting pressure on you. So now we've got the two forces. We've got 5.5 times 10 to the minus 7. We've got 3.7 times 10 to the minus 7. And now we just need to get the net force. Now remember what our rule is. F net is equal to winning forces minus losing forces. Which of these two is winning?
The 5 come way.
Yeah, no, you're right. So the 5.5 times 10 to the minus 7 is winning. Because it's bigger. You just look which one is the bigger one. And then we're going to minus the losing force, which is the 3.7 times 10 to the minus 7. So winning force minus losing force, and then you get your answer. 5.7 minus 5.5 times minus 3.7. That shouldn't be a very hard calculation. What's that? 2 point something. 1 point something. Calculator, guys.
I got 1.8 times 10 to the minus 7.
Thank you.
Same.
1.8 times 10 to the minus 7. And it's a force, so it's newtons. And because the question said magnitude, I don't have to put a direction. But if the question didn't say magnitude and they just said net force, then you would have to put a direction. What would the direction be? Which direction is winning?
Left.
To the left.